Okay, good day. So, for the continuation of our discussion regarding the introduction in nuclear physics, I'll be just trying to record this lesson in order for you to have ample time and to allot it for the different activities that you're having in my subject or in other subject. Okay, so I'll be going to discuss radioactivity. Okay, so what is basically the meaning of radioactivity? So radioactivity, or often uh, called as radioactive decay, it's all about the spontaneous process of nuclei undergoing any change because they are unstable elements. Okay, and in order for them to become stable, they tend to disintegrate. Okay, that is what you call the radioactive process or the radioactivity of a particular nuclei by emitting some particles or rays. So what is basically a nuclide? So a nuclide, it is a specific type of nucleus. So whenever you have any particular element, all those elements consist of what you call the atoms. Okay, and in that particular atoms, we define it that it has this what you call the nucleus. Okay, so pertaining to a specific type of nucleus, the terminology being used is called the nuclide. Okay, some example of elements or nuclides having this kind of process being radioactive are the uranium-238 and the carbon-14. So majority of the time, uranium-238 is used in uh, atomic bombs, okay, in nuclear reactors, while the carbon-14C, which is lesser radioactive, is used in carbon dating. Okay. So these nuclides, often also called as radionuclides or radioactive isotopes, or just a short of radioisotopes, these are nuclides whose nuclei undergo spontaneous decay, okay, or disintegration by any means. Dahil nga sila ay unstable, okay, kaya ang tendency nila is gusto nila maging stable ng mga nuclide, they emit some particles or rays na tinatawag. So, doon pumapasok yung sinasabi nating radioactivity. Okay? So, substances that give off such radiation are said to be radioactive. So there are these things that you will encounter in radioactive decay. The first thing is you have this what you call the parent nucleus. So what is this parent nucleus or the original nucleus of a radioisotope? This is the original nucleus before any said decay, okay, or disintegration. So kapag ang isang element ay unstable, yung original na nucleus, ang tawag natin doon ay parent nucleus. Okay, while the daughter nucleus or the daughter product, it is the resulting nucleus of that nuclide after the decay or after the said radioactivity. Okay? So parent nucleus, parang siya yung original. Okay, while the daughter nucleus, this is the product, okay, na nangyari sa ating process. So radioactive nuclei can decay or disintegrate in three common ways. Actually, there are, I think, six ways, but these are the often na na-encounter in textbooks, okay, in uh, researches, in observations, the alpha decay, the beta decay, and the gamma decay. So these are the three that includes, okay, in your LAS. Okay, so what are these decays? So let us try to examine what is an alpha decay. Alpha decay, this is the disintegration or the decay of a nucleus into another nucleus. So meaning to say, in alpha decay, you will encounter here from a parent nucleus, it will result into other daughter nucleus, giving us a new element. So for example, if a uranium try to disintegrate, okay, the resulting nucleus would no be longer as uranium, but it will form another element. Okay, not only forming other element, but also it has the emission of what you call the alpha particle. Okay, dahil nga sabi natin, ang radioactivity, it emits radiation. So for the case of alpha decay, it emits this what you call alpha particle. It is denoted by the Greek symbol alpha. Okay, and this alpha basically is a helium nucleus. Okay, an energetic nucleus, okay, being emitted in an alpha decay. So this alpha particle is basically the helium nucleus. So if you will try to see the chemical designation of a helium nucleus, it has a mass number of 4 while the atomic number is 2. So basically, helium nucleus have 2 protons. Okay, and at the same time, if it have 2 neutrons. Thus, in alpha decay, you can say that if this helium nucleus is being emitted, therefore the parent nucleus tend to lose two protons. Okay, because it emits an alpha particle. Tama, no? So this is a helium nucleus having this chemical designation. Therefore, in alpha decay, you will expect that the parent nucleus will lose two protons. Okay? Because it emitted an alpha particle. Ganon yung nangyayari sa alpha decay. It will form a new element with the emission of this alpha particle. Thus, the parent nucleus gives off two protons or it will lose two protons. Okay? That is the alpha decay. While for the beta decay naman, this has something to do with the neutron, okay, of a given element. So in beta decay, a neutron is being transformed or splitted into a proton with the emission of the beta particle. So ang nangyayari sa beta decay is that yung neutron is i-split siya or nagtatransform siya into a proton. Okay, so basically nagge-gain ng proton sa beta decay na isa, okay, with the emission of some beta particle beta. Okay, so this beta particle in beta decay is called the electron, having the chemical designation of 0, -1, and E. Okay, so ang nangyayari sa beta decay is nagge-gain siya ng isang proton. And at the same time, naglo-loss siya ng isang electron dahil nga doon sa transformation ni neutron. Okay, the neutron being transformed into a proton and at the same time with the emission of this electron na isa. Okay? And the gamma decay, the simplest among the radioactive decay, it just occurs when a particular nucleus or nuclide emit a gamma ray or energetic ray denoted by some gamma. Okay, and the nucleus basically becomes less energetic. Okay, so dito walang pagbabago ng nucleus. So if uranium try to disintegrate, okay, the after element is still uranium unlike the alpha decay. So maliwanag sa atin yun that in alpha decay, it will form a new element with the emission of the alpha particle. Thus, it will lose two protons. While in beta decay naman, it will gain, okay, a proton and at the same time it will emit a beta particle or the electron itself. Thus, it will lose uh, an electron. Okay? So, ganun ang nangyayari sa beta decay. And in gamma decay, you have an energetic nucleus that will just give off some energetic particle called the gamma ray and it will become less energetic. Okay? That's why in observations, they found out that if you have this source of uh, radioactivity, okay, the tendency if you have these charged conductors, the negative plate and the positive plates, the alpha particle or the helium nucleus tend to attracted into this negative plate because in alpha nucleus, it is having two protons being lost, okay, in the process. Kaya ang tendency niya is mag-attract siya dito sa negative plate. While in the beta decay, it will lose an electron, gaining a proton. So, ang tendency niya is mag-attract siya sa positive plate dahil nga ang na-lose in beta decay or emission is an electron. While in the gamma, it will just travel, okay, between these conductors because this is just an energetic particle. Okay? So let us try to examine this given example in the radioactivity or radioactive decays. So for alpha decay, okay, sorry for this, this is actually 90. Okay, na ano lang siya. In alpha decay, we have this example, the thorium. Okay, thorium having a mass number of 232 and atomic number of 90. So if uh, it undergone an alpha decay, the resulting chemical equation would be this. Okay, you have here the hint of the helium nucleus 42He. Therefore, you need to think, okay, some of the chemical or element that would balance the mass number as well as the atomic number. So if the helium nucleus in alpha decay has a 4 mass number and 2 atomic number, you need to add 2 here in order for you to get a balance of 90 na atomic number dito. That's why meron tayong 88 dito sa part na ito. And at the same time, for the mass number, you have here 228, okay, and 4 for this. If you will notice, 228 plus 4 will just give you the original parent nucleus of 232. 88 plus 2, it will give you the original nucleus of 90. Okay, that's why you have here 228 and 88 radon plus 42He. So this is an alpha decay, which is true in the previous statement that we have imposed, that in alpha decay, it will lose 2 protons. So from the atomic number of 90, it loses 2 protons, naging 88 dito. Nasaan na sir yung 2 protons? Nandito dito sa helium nucleus, kasi ito yung give off niya na radiation. Okay? So nag-lose dito ng dalawang proton, resulting into a new element. Okay, which is this uh, radon, no? Na tinatawag. So this is an example of alpha decay. Ang pinaka-hint is kailangan makita mo yung alpha particle or the helium nucleus in order for you to conclude that is an alpha decay. For the beta decay naman, you have this 14,6 carbon, okay, transposing into another nucleus or the daughter nucleus into 14,7 nitrogen plus 0 negative 1 E. Okay, dito ang pinaka-hint sa beta decay is the electron emission. Okay, pero sabi natin kanina sa beta decay, nag-gain to ng isang proton. Okay, kaya nga yung 6 na atomic number in the parent nucleus of this carbon became 7 here. Okay, so para rin siyang alpha decay na nagpo-form ng new element. Ang pinagkaiba lang nila is that yung mass number, okay, is hindi nagbago. Okay, kung 14,6 carbon dito, ang naging resulting nucleus niya is 14,7 nitrogen. Okay, walang pagbabago sa number, but you will notice that in atomic number, it increases 1. Okay, which means it gain a proton. Okay, so ganun pa rin ang setup, kailangan lang balance pag pinag-add mo yung mass number at saka atomic number. So 14 plus 0 is just still 14 na original sa carbon. While here, 7 plus negative 1, it will result into 6. Okay, sa inyong basic algebra, di ba? 7 plus negative 1 is just similar to 7 minus 1, which will just result into 6. Okay, so sa beta decay, ang pinaka-hint is the emission of electron. Okay, while in gamma decay, ito mas madali lang. Okay, you will just try to examine or observe the asterisk sign. Kung nakita kayo ng asterisk sign sa element na yan or sa nuclide na yan, it means that that nuclide is actually energetic. Okay, and if it will takes place a gamma decay, the resulting nucleus is still the same element. Okay, with the emission of the gamma particle. Okay, maarting Y. So, ganun kasimple pag gamma decay. And just remember, in a nuclear decay equation, the sum of the mass number A, yung nasa upper left, okay, and the sums of the atomic numbers, yung nasa lower left, okay, must be equivalent on each side. Okay, yung pinaka-hint pag tayo ay nag-examine ng mga nuclear decay equations. Alright, so I think that is clear to everyone. So another example of an alpha decay. So if you have given the parent nuclide 238 uranium, okay, having an atomic number of 92, pag sinabi niya it will undergo an alpha decay, what would be the equation for this process? So paano natin isi-set up? Paano kung hindi binigay sir yung pinakabuong decay equation? Okay, madali lang. So kung sinabi niya na yung uranium-238 ay mag-undergo ng alpha decay, dapat pumasok agad sa isipan natin that it will emit a helium nucleus or an alpha particle. Okay, kaya kailangan mo magsulat dito ng 42He. Okay, addition for this 42He. And then you have this unknown element. So sa alpha decay, alam din natin na magpo-form siya ng new element. Okay? At ano ang mangyayari sa alpha decay? Maglo-loss siya ng dalawang proton dahil nga dito sa helium nucleus. Okay? So, kaya meron kang idea ngayon na sa atomic number, 92 yung original niya sa parent nucleus, magiging 90 na lang siya dito sa part na ito. Okay? Which will be consistent in the addition of the atomic number, 90 plus 2. It will give you the original 92. Okay? So, kung nagbago yung atomic number, magbabago rin sa alpha decay yung mass number. So, meron ka ng 4 sa helium nucleus, kailangan mo mag-add ng 2, 3, 4 para makuha mo pa rin yung balance na to. Now, you have these numbers, 2, 3, 4, and 90. Ang kailangan mo na lang isipin is yung element. Okay? So, paano natin malalaman yung element na yun? By just simply looking in the atomic number, which is 90. Okay? So, anong gagawin natin? Mag-cheat tayo. Okay, gagamit tayo ng periodic table of element in order for us to identify which element have its atomic number of 90. So, based sa ating periodic table of elements, makikita natin ng element na yon is actually thorium. Okay, that is why for the nuclear decay equation of uranium-238 92 undergoes an alpha decay, it will result to this daughter nucleus of 234 thorium plus 42 He or the helium nucleus. So, ganon kasimple. So, these are the 5 common forms of nuclear radiations, yung alpha, beta, and gamma. Some of it are the positron and neutron. So, yung positron, kabaliktaran lang naman yan ng beta. Kung sa beta, nag-emit ng electron, sa positron naman, nag-emit ng proton. Okay, tapos nag-gain siya ng electron. Okay, unlike sa beta, nag-gain ng proton, nag-lose ng electron. Sa neutron naman, nag-loss lang ng neutron. Okay, pero hindi naman masyadong na-encounter yan sa LAS, yung mga positron and neutron na ating tinatawag. Okay, so this is an example of the decay series of uranium-238, okay, that will lead into lead-206. Okay, at pag sinabi nating decay process, hindi yan nangyayari ng isang oras lang, kalahating oras, nakadepende yan sa element. Okay, which will be discussed in the latter part or in the preceding discussions natin. So, uranium-238 that undergone alpha decay, naging thorium, tapos nag-undergo ng beta, naging palladium, tapos beta ulit, naging uranium, and repetitive process hanggang makarating siya dito sa lead-206. Okay, kasi nga nagdi-disintegrate siya. Okay, yun yung sinasabi nating radioactivity. How do we identify if the nuclide is actually stable or not? Okay, which nuclides are unstable or kilala natin as being radioactive at sino naman yung mga stable? Okay, there is a pattern actually. Most stable nuclides have an even number of both protons and neutrons. So, ibig sabihin nun, pag stable na yung nuclides, even number yung kanyang protons at neutrons. Ano ba sir yung even number? Sinabi natin even number, ito yung mga digits or yung mga numbers which is divisible by 2. Okay? For example, 2, okay, 4, 6, 8, 10, 12, and so forth and so forth. Okay? Yun yung mga stable nuclides. Yung protons at saka neutrons ay even-even. Okay? Pag unstable nuclides naman, add number of both protons and neutrons. Add siya. Okay? Hindi pwedeng add even. Dapat parehong add. Pag sinabi naman natin add number, these are the numbers or digits, values na hindi divisible by 2. Wala kami makuhang exact na value. For example, 1, okay, 3, okay, 5, 7, 9, 11, and so forth and so forth. Yun yung mga add nuclides. So there are 3 categories if the nuclide is said to be radioactive. Okay, the first criteria is dapat yung atomic number niya is greater than, okay, this is greater than 83. Okay, pag yung atomic number ng isang parent nucleus is greater than 83, that nuclide is said to be radioactive. Yan lang yung unang criteria in order for you to say that the given nuclide is actually radioactive. If Z is greater than 83. The next criteria is that the number of neutrons must be less than, okay, the number of protons. Okay, if N is less than the number of protons, that nuclide is said to be radioactive. Okay, except for this. the hydrogen and the helium, the isotope of helium-3 2. Okay, ito kasing hydrogen wala siyang neutron, 'di ba? So sa-subtract mo lang itong nasa taas tsaka baba para makuha mo yung number of neutrons. So 1 minus 1 is 0. Tapos 1 ang atomic number. So 0 is less than 1. So exempted daw itong hydrogen na ito. And at the same time, this helium isotope. Okay, so first criteria is atomic number must be greater than 83. The next criteria is that the number of neutrons must be less than the number of protons. And the last is the protons and the neutrons must be an add-add nuclide. Okay, dapat add-add sila. Except for this again. Yan, yung mga yan, except yan. Kasi 2 minus 1, meron siyang 1 neutron at meron din siyang 1 proton. Okay, which is an add-add number. So, exempted yung mga yan. So, tandaan nyo itong tatlong criteria na to. So, tingnan natin dito sa next example. Identify the radionuclide in each pair and state your reasoning. Bakit siya yung kinonsider as radioactive? So, the first example is that you have given 282 of lead. Okay, this is lead. And the isotope of helium na 22286. I don't know if this is actually helium no? Kung may ganitong isotope pa. Pero dahil itong binigay, di yan na lang ang sundin natin. So mapapansin mo agad is that meron kang assumption na radioactive ang isang nuclide kapag ka daw ang atomic number is greater than 83. So madali mo agad makita dito na itong si lead is 82. Okay, tapos itong si helium is meron siyang 86. So masasabi mo in this pair that this 22286 helium is the radioactive nuclide. Why? Because Z is above 83. Okay, ganun kasimple. Hindi kailangan na yung tatlong assumption ay masunod para masabi mo na itong nuclide na to ay radioactive. Okay, masunod lang niya yung isa doon is goods na yun. That's why in the first pair, you will conclude that this particular nuclide is the radioactive one because the atomic number or the number of protons is above 83 for this case. I hope that is clear to everyone. Okay. For the next example, you have 1910 neon and the 2010 neon. Okay, so yung unang assumption natin that atomic number must be above of 73 ay hindi na applicable dito sa ating pair na to. Ibig ba sabihin hindi na sila radioactive? No. Okay, kukuha tayo dun sa ibang assumptions natin or sa criteria natin. Okay, dahil nga 10 lang ang atomic number nito. So kung mapapansin mo, pwede natin gamitin yung second rule. Okay, or third rule. Tama, no? Ano yung second rule? The number of neutrons must be less than, okay, compared to the number of protons. So, pwede mong gamitin yun dito. So, paano mo malaman yung number of neutrons? Subtract mo lang yung mass number dito sa atomic number. That's why 19 minus 10 gives you 9. 9 ang neutrons nito, tapos 10 ang protons. So, ano makikita natin doon? Yung number of neutrons ay less than compared sa number of protons. Okay, how about this one? 20, 10 neon. 20 minus 10, you have 10 neutrons. So atomic number is 10. So 10 neutrons, 10 protons. Equal lang. No? So by in this pair, you can conclude that this radionuclide is actually the radioactive one. Because the number of neutrons of this particular nuclide is less than compared to the number of protons. Okay, 19 minus 10, 9, and the protons is actually 10. So 9 is less than 10. Okay, so I hope that is clear to everyone. 9 is less than 10. Ito kasi equal. 10 is equal to 10. Okay, yan kasi yun. Isa. Okay, in the last pair naman, you have 6329 copper and 6429 copper. Okay, so which of this pair is actually the radioactive or considered as a radionuclide? Again, hindi na naman pasok yung ating criteria that Z must be above 83. Okay, pwede rin naman natin tignan yung number of neutrons compared to the number of protons. Okay, pero kung titingnan mo, 63 minus 29 at 64 minus 29, ang resulting is that n is greater than p. Tama, no? 63 minus 29 is n is greater than p. That's why itong assumptions na ito is hindi natin pwedeng i-apply. So, meron tayong pinaka-last option which is the add-add nuclide. Okay? Dapat daw yung number of protons and neutrons ay add-add pair siya. Okay? Hindi add-even, hindi even-even. Okay? Dapat siya ay add-add. So, try natin. 63 and 29 copper. If you subtract that mass number to the atomic number, 63 minus 29, it will give you actually 34, okay, neutrons. Tama, no? Yung N na yan is neutrons. Tapos meron siyang 29 protons. Ang tanong, add-add pair ba yan? Si 29 ay odd number. Tama? Ito ay odd number. Pero si 34 hindi siya odd number kasi divisible siya by 2. It is actually an even number. Therefore, this 60-29 copper is not considered to be radioactive. Okay? So obviously, this would be the radioactive part. No? So 64 minus 29, it will give you 35. Okay, 35 neutrons. Okay, and for the protons, it is actually 29. 29 protons. So 35 is actually an odd number, and 29 is also an odd number. That's why in this pair, it is considered to be the radioactive one because of this criteria na meron siyang odd-odd pairing. Okay, so I hope that is clear to everyone. And for the pairing effect, di na natin masyadong discuss. Okay. So for the next meeting, we are going to discuss yung sinasabi ko kanina, gaano ba katagal mag-disintegrate itong mga radioactive elements na ito, yung mga radioactive isotopes na ating tinatawag. Okay, so I hope in this discussion you have learned the significance of radioactivity and the three common ways a nuclide can disintegrate: the alpha, the beta, and the gamma decay, and what are the significance of those decays, and how to identify if a given pairs of elements is said to be radioactive using the three criteria that we have imposed in our discussion. Okay, so I hope you have learned in this and you can complete now answering the task 2 of your LAS. Good luck everyone and God bless you. Stay safe and bye bye. Yun lamang.